Hello, and welcome to this lesson on finding the volume of cylinders, cones, and spheres. This lesson is going to be a lot of using our formulas from the formula sheet. If you look at a formula sheet for the 8th grade, you'll see there is a formula for the cylinder, cone, and sphere volumes. So really that's what it's going to come down to, with a little bit of problem solving in there as well. This 100 question says, how do I apply formulas to find the volume of cylinders, cones, and spheres? Did you know the sun, which is a sphere, has a volume of 1.41 times 10 to the 18th kilometers cubed? Okay, so that number may not look so big if we write it like that, but what if we wrote it out in standard form? That's quite a bit bigger. It's actually so big you could fit 1.3 million Earths inside of it. And we can figure all this out by doing some simple formulas. Like, for example, we can measure the diameter or the radius of the sun, since the sun has a radius of about 700,000 kilometers. We just take 700,000, throw it into our volume of a sphere formula, and boom, it spits out the volume. So, vocabulary. Volume. Well, volume is the amount of space a three-dimensional object takes up. A gallon is a volume. You're buying a gallon of milk. You're not buying it by the pound. You're not buying it by the inch. You're buying how much milk is there in that container. That's a volume. When you buy a trash can, you buy it by gallons. A 2-gallon trash can be very, very tiny. Most kitchen trash bags and trash cans are about 13 gallons. Those like white trash bags you put in your kitchen trash can, those are 13 gallons. The big trash cans you keep outside of your house, you put the things in, those are closer to 30 gallons. Okay, so it's the amount of space that you could put inside that thing. Okay, a radius is the distance from the center of the circle to the outside. So that would be kind of like the spoke of a bicycle wheel. It's from the center to the outside. All of these should be the exact same distance. They are all radiuses, radii. A diameter, though, is the distance from one point of a circle through the center to another point. So it's essentially going to cut your circle in half as long as it goes through the center. There is such a thing. Oh, that's a terrible circle. There is such a thing where it goes and it touches 2 points of the circle, but does not go to the center. Like if my center was right here, this is not a diameter, where this is. This is called a chord, spelled C-H-O-R-D. That is a chord. That's just a line that touches 2 points of the circle, not through the center. A diameter touches 2 points of the circle through the center. This is the one we want for today. And hopefully you can see a connection between a radius and a diameter. If a diameter goes the whole way through a circle and a radius goes halfway, a diameter is just 2 times the radius. This length here, there's one radius, there's another radius. So 2 radiuses make a diameter. The formulas. Now, these pictures were taken directly from the formula sheet. So you have the volume of a cone. It gives us, heights and a radius. You see it's labeled in the picture. And so the formula is V equals 1/3 pi r squared h. This pi r squared is the area of the base times by the height times by 1/3, because it kind of goes in. You notice that this formula and this formula look very similar. The only difference is this cone has the 1/3. V for the cylinder, V equals pi r squared h. Pi r squared h. So they're very similar. Again, the difference is the cone is the 1/3 because it's kind of tapered. So it doesn't have the same volume as this, even though if the radiuses and the heights were the same. For a cone, or I'm sorry, for a sphere, it is 4/3 pi r cubed. Make sure you pay attention to that exponent, that cubed. A lot of folks kind of get wrapped up and they put a squared in there. It is a cubed. So that means to the third power. The disk below has a volume of 2,200 centimeters cubed. What is the approximate height of the disk? Okay, so first off, you would write down the appropriate volume formula. This is a cylinder, so V equals pi r squared h. We would then plug in all the information that we know. I know the volume is 2,200 because it says so right there. I know pi is 3.14, or approximately 3.14. I'm allowed to use that number. You also in your calculator have this pi button you can use. It gives you more digits. The radius of my cylinder, from the center to the outside is a radius, so my radius is 15. And my height, I don't know. In fact, that's the question. What is the approximate height of the disk? So I'm just going to leave it as h. Now, if we would solve this equation, we'd be done. And that might be a little confusing for you if you've never solved an equation like this before. Here is our variable, our h. So we'd want to get this h by itself. We would start by simplifying this junk here. Now, when I do this, I'm going to zoom in a little bit, since we don't really need the picture anymore. I do actually like using 3.14. There's nothing wrong with using the pi button. We will get the same approximate answer. I just like it because it gives me simpler decimals. Okay, 15 squared is 225. So I simplified my exponent piece. I'm going to multiply these together. 3.14 times 225 is, oopsie, I see it only put 3.4. There you go. 2200 equals 706.5 h. Now, our goal is still to get the h by itself. We're solving this equation. So in order to do that, since this is a multiply, 706.5 times h, we're just going to divide by 706.5 on each side. And h equals, I don't know, 2200 divided by, instead of having to type this whole thing in, I can just hit second answer. And we got 3.11. Ooh. I am still rounding to my nearest hundredths, so I rounded to here. This was a 4 or less. My 1 stays the same. So my answer is the height is approximately 3.11 centimeters. And you could always double check your answer, because now you know the height and the radius. If you take these numbers and plug them back into this formula, we should get a volume of about 2,200. So check this out. I'm actually gonna do that. I'm gonna use the pi button. So I'm gonna type in this, but using the numbers. So pi times my radius, which was 15 squared. That's radius squared, 15 squared, times by my height, which is 3.11. So volume equals pi r squared h, pi r squared h, and that should give me a close to 2,200. Now, why is it off? Well, we rounded a couple different times in the problem. Specifically right here is probably the biggest rounding error we did. It's not an error, it's just, it says an approximate height, so that's approximately how big it is. If I would have kept all of those decimal places of that irrational, or of that big ugly decimal, it would be rational, but the big ugly decimal, we would get closer to our answer. But that's okay. It is an approximate answer, and there we have it. Okay, here's one for you. It says Bill got an ice cream cone and wants to fill it with ice cream and have one scoop on top. If the cone is 6 inches tall and has an opening of and the opening has a diameter of 3 inches, what is the volume of ice cream inside the cone? So if you could please go ahead and pause the video and do this problem on your own right now. When you're ready to continue, hit play and we'll go through it together. All right, so first thing I would do is I would label my picture. So it has a height of 6 inches. And the diameter of the cone is 3 inches. So our diameter is the whole way across. Next, I would look up the volume formula for a cone. V equals 1/3 pi r squared h. And I would start plugging in what I know. I don't know the volume. That's what we're trying to find. 1/3 of, I'll just use the pi button, or I'll use that for now. Pi. Radius. I don't have a radius. They gave me the diameter of this. How do I change a diameter to a radius? Well, if a radius goes from the center of the circle to the outside, and a diameter is the whole way across, diameter is just 2 times bigger. So if I cut this in half, 3 divided by 2 pieces, cut it in half, each piece would be 1.5 inches. And that would be my radius, 1.5. I'm going to square it. And my height is 6 inches. Now, this is all multiplication. 1/3 times this, times this, times this. I could actually just type this whole thing in as long as you do it accurately. 1/3 times pi times 1.5 squared. Probably didn't need the parentheses here, but that's okay. Times 6. So I'm making sure the calculator understands what we're doing. It is 1/3 times pi times 1.5 squared times 6. That's the same thing here. And we got an answer of 14.14, rounding to the nearest hundredths. So 14.14 inches cubed. Volume is a cubic measurement. The unit is always inches cubed. Just like when you're finding area, it's inches squared. If you're finding perimeter, it would be just inches. Well, volume is always in inches cubed because we're talking about a 3-dimensional object, so it's being measured in 3 dimensions. So that's how much ice cream would be inside this cone, 14.14 inches cubed. Letter C. This is a very common type of problem where you have 2 different objects and you want to find like the volume inside of one of them. So here it says Doug has a bucket that is 12 inches tall and has a radius of 6 inches filled completely with water. So our picture is labeled so far appropriately. Doug pushes a basketball with a diameter of 10 inches. So that's not labeled, so I'm going to label him. The basketball has a diameter of 10 inches, completely into the water, overflowing the water in the bucket. Right? Because that would happen. Like if this bucket was completely full of water, and then a dude started pushing a basketball into it, water's gonna spill out over the side. Well, the question is, well, how much water is left in the bucket? So we want the volume of the water in the bucket. Now, if you think about this right now, originally, the volume of the water would have been the volume of the cylinder, because if this bucket, the cylinder, was filled completely up, we would have a volume of V equals pi r squared h, with our 6 as our radius, our 12 as our height. That's how much water would have been in the bucket originally. Because if this water was completely full, we'd have that much water. But when a bunch of it spilled out, how much of it spilled out? Well, when this basketball gets pushed into the water, the basketball pushes out that same amount of water as its own volume. So we're going to take the volume originally, and we're going to subtract the volume of the basketball. So imagine right now, in this bucket, if we would take out, or imagine this basketball's not here, all that would be left would be the water in the bucket. So that's what we're going to do. So the volume of a basketball, the formula is V equals 4/3 pi r cubed. So I'm going to start getting rid of some of this just to simplify the problem a little bit. Okay. So 4/3 pi. My radius of the basketball. Ooh, I think I labeled my picture wrong. Doug pushes a basketball with a diameter of 10. Like, I looked at this and I said, wait, how can this 10 be smaller than that 6? It wouldn't even work. That's because I made a boo-boo. The basketball has a diameter of 10. That would be this. That's 10 inches. Okay, so then what would be my radius? Half of it would be 5. That makes much more sense because now the basketball could actually fit inside the bucket. The radius is smaller than that radius. So that's the math we'd want to do. Now, would I try to type that whole thing in my calculator in one shot? No, I probably wouldn't. I would break it down. So I would do 3.14 times. I actually know that 6 squared is just 36, so I'm going to type in 36. If you don't know it, you can type in 6 squared times 12. So this is the volume of the water that was originally in the bucket. This is the volume of water. And that is 1356.48. Now, I'm going to find the volume of the basketball. So 4/3 times 3.14 times, I know 5 cubed is 125, but I'm still going to do 5 cubed on the calculator. So when we type that in, we do 5 caret 3. See, 5 cubed. And we got 523.33. I'm still keeping my rounding to the nearest hundredth thing going. And then finally, I would subtract these two values. Water minus the the volume of the bucket minus the basketball is just how much water is left inside. So 1356.48 minus 523.33 is 833.15. And since we're talking about a volume, our unit would be inches cubed. That's the volume of the water. And I'll even label that. Volume of water equals. There we have it. So this is kind of a compound object. We had to take away the one from the other to get how much space was left inside. Overall, not too bad of a problem. Once you knew how to set it up, it was fairly easy. Okay, letter D, this one's for you. It says, at a party, Lexi went into a bouncy house in the shape of a half sphere, called a hemisphere. The bouncy house had a radius of 8 feet. What is the volume of the bouncy house? Well, go ahead and do the problem right now. When you're ready to continue, hit play, and we'll go through it together. So first thing I would do is I would label my radius of 8 feet. And then I would write down my formula. So the volume of there's no volume of a half sphere, but could we just find the volume of a whole sphere and then cut it in half? Yeah, we can. So volume of a sphere is 4/3 pi r cubed. V equals 4/3 pi, my radius is 8 cubed. This I can type in my calculator now. 4/3 times pi. I like to use 3.14. If you like to use the calculator pi button, we'll get slightly different answers, but we'll still be pretty darn close. Times 8 to the 3rd power is, volume is 2,143.57. So that would be 2,143.57 feet cubed. Oopsie, I guess that's not quite done, is it? So that's the volume of the sphere, but our bounce house is not a sphere, it is half of a sphere. So I almost forgot to take that and cut it in half. So let's because that's not our final answer. So we're going to take that 2,143.57 and we're going to divide it by 2. We're cutting it in half. Oops. Yep. Okay. Divide by 2 equals 1071.79. Again, rounding to the nearest hundredths. The 5 makes the 8 round up. Now I can put feet cubed. All right, so this would have been the volume of a full sphere. See, that's just a regular sphere formula. Then we had to take that volume and cut it in half because it is half of a sphere. And that's how we got our final answer. And a lot of times it's easy to make mistakes. Now, what caught me when I started putting down my answer is I went back up and I quickly glanced at my picture and I glanced at my problem, and then alarms were going off in my head that this was the volume of a full sphere, not a half. I forgot to divide by 2. That's something you should be doing as well, is you should make sure your answer makes sense, or make sure you're answering the actual question, which I didn't do at that time. A softball has a radius of 2.94 inches, and a baseball has a diameter of 3.8 inches. How much bigger is the volume of a softball than the volume of a baseball? Okay, all right. Softball, baseball. Softballs are a little bit bigger. It says the softball has a radius, that's from the middle to the outside, of 2.94 inches. The diameter of a baseball is 3.8 inches. So both of these objects are spheres. So in both cases, we're going to use the sphere formula. V equals pi r squared. Let's try again. 4/3 pi r cubed. V equals 4/3 pi r cubed. So in both formulas, we need a radius. So it would be wrong to plug this 3.8 in right now for the radius, because this is a diameter. We're going to have to convert this into a radius. Now the first one is fairly easy because that's already a radius. So I can plug it in and start typing numbers. 4/3 pi 2.94 cubed. 4/3, oopsie, delete, times pi times 2.94 cubed equals, I did a quick double check of my calculator, so I paused. I was looking at this and making sure everything matched up the way it should. 106.39. Okay, so that's the volume of the softball, 106 cubic inches. Now, volume of baseball. Well, again, we need to convert this diameter to a radius. I need a radius to throw into my formula. So I'm going to take the 3.8 and I'm going to cut it in half, divide by 2. That gives me a radius of 1.9. So V equals 4/3 times pi times 1.9 cubed. And I can type that in the calculator. 4/3 times pi times 1.9 to the 3rd power. 4/3 times pi times 1.9 to the 3rd power. Okay, it all looks good. Giving us a volume of 28.72, rounded to the nearest hundredths. 6 makes the 1 round up. Okay, so I found the volume of both. Now let's go back and look at the question again. So softball has a radius of that, baseball has a diameter of that. How much bigger? That phrase, how much bigger, is a phrase that's been following you ever since elementary school, and it's going to keep following you. That phrase is a subtraction. We're looking for a difference. How much bigger, how much stronger, how much colder, how much heavier. All of those are subtraction questions. We're looking for a difference. So I'm going to take 106.39 minus 28.72. 106.39 minus 28.72 is 77.67 inches cubed. That is my final answer. That is how much bigger the softball is than the baseball. It is 77.67 cubic inches bigger. Found the volume of the one, found the volume of the other. Because this is how much bigger, we subtracted. If the question was how many times bigger, we would have done a division. Letter F. 3 friends are sharing a soda from a can. Maybe they pour it each into their own individual cups and make it equal. The dimensions of a soda can are shown below. Those are the approximate actual dimensions of a soda can. If the 3 friends each drink an equal portion, how much soda would each friend drink? Okay, so this is a problem for you to try. Go ahead and pause the video and do this right now. When you're ready to continue, hit play, and we'll go through it together. All right, there's 2 different ways you could game plan this problem properly. Way number 1, you could find the volume of the can. That would give you like the whole soda, and then you could divide it by 3. I'm guessing that's what most of you did. The other strategy you could use is you could take and imagine cutting the soda, the whole can, into 3 equal sections. You could actually take that 4.8 and divide it into 3 pieces and find that each person would drink about 1.6 inches of the soda in the can. It's a different method. They both work. So you could use this as your height and this as your, change that into a radius, and you would find your volume. But I bet most of you did this way, found the volume of the can, and then divided by 3. So that's how we're going to do it. So the volume of a can, a cylinder, is pi r squared h. That's pi. My radius is not 2.5 inches. My radius would be 2.5 divided by 2. This is a diameter. I want halfway of the circle, which is 1.25. And my height is 4.8 inches. So now calculating, we've got 3.14 times 1.25 squared times 4.8. I'm just double checking, make sure I didn't make any typos. All looks good. So the volume of the can is 23.55 inches cubed. Now that's before we do any division. That's just how much total soda would be in the can from the beginning of the problem. Now, if we follow kind of like our game plan here, we divide the whole soda by 3. Divide by 3. We get, each friend gets a volume of 7.85 inches cubed. So each person gets 7.85. That gives a total of the whole volume of the can, and we're good to go. Letter G. Crystal was told by her mom she could get 1 scoop of candy. There are 2 scoops, and both scoops are shaped like cones. Given the dimensions below, which cone should Crystal use if she wants to get the greatest amount of candy? So scoop A looks like it's 15 tall and would be a total of 30 wide. Scoop B is 30 tall and 15 wide. Who knows? They might even give the same volume of candy. But the only way to find out is by doing it. So, and this is actually the end. I saw the word summary down there. And I might add an extra page in here just for space. We'll see. We'll see if I need it. Okay, so scoop A. Volume equals, a cone is 1/3 pi r squared h. 1/3 pi. This picture already has a radius from the center to the outside is my radius, so I'm just going to plug in 15 squared, and my height is 15. I almost put an h. And actually, I can just type that straight into the calculator right now. So, 1/3 times pi times the radius squared times the height. And I'm double checking, 1/3 pi radius squared height, okay, equals 3,532.5 centimeters cubed would be the volume of this scoop. Scoop B, volume equals, it's still a cone, so 1/3 pi r squared h. 1/3 pi. All right, what is my radius? Well, a radius would be halfway of a circle, so I'm going to take this 15 and I'm going to cut it in half. Let's divide it by 2. Should be 7.5 squared, and my height is now 30. Okay, that is ready to type in the calculator. 1/3, get out of there, 3.14, oopsie, I forgot to hit my times. It actually would have worked, but I like having that times in there. Times 3.14 times 7.5 squared times 30. So double checking, 1/3 pi 7.5 squared times 30. All right, all looks good. We got 1,766.25 centimeters cubed. So, given the dimensions below, which cone should Crystal use if she wants to get the greatest amount of candy? Well, out of these volumes, Scoop A would give a significantly more, almost double the amount of candy. Actually, is it double? Yeah, it's exactly double. So Scoop A gives double the amount of candy as Scoop B. I took this number and times by 2. It gave me that same number. So she should definitely use Scoop A. We should say that. Crystal should use Scoop A. There's our good final answer. We actually answered the question. Which scoop should she use? Crystal should use Scoop A. Summary. In your opinion, what is the most important thing to remember to do when solving problems involving volume? I could think of a couple good, really important things. What do you think is the most important thing? And if you would make a list of a couple different things, by all means do that. But go ahead and pause the video, think about this, And when you're ready to continue, hit play, and we'll go through it together. All right, things like write down your formula. A lot of students don't write down their formula. They just think they have it in their head, and they make lots of little mistakes. It doesn't hurt to write it down. It doesn't hurt to look at it. Look it up. Second thing, make sure your picture is drawn and labeled properly. For example, if you need a radius and your picture gives you a diameter, make sure you draw the radius in the picture. That way you don't make silly mistakes. The next part of the problem would just be like, doing the math and typing in the calculator. There's not too much there. The last thing I would say is, or maybe say double check your numbers. There, that'd be like the middle of the problem. Double check your numbers. And the last thing is, make sure your answer, the number you got, the solution you got, is actually the answer to the question. Make sure you went through the whole process. So check your answer. And that doesn't always mean redo the whole problem again in your head. A lot of times it's just like this problem. Did you divide by 3? You're supposed to have. If you didn't, that might be a boo-boo. In the previous this problem here, I almost forgot to divide by 2, but thankfully I went back and I double-checked my question, and I noticed it was half of a sphere, and so I divided by 2 to get my final answer. So those are the things I would say would be kind of important things to do as you're solving these problems. All right, thank you so much for watching this lesson on volumes of cylinders, cones, and spheres. Until next time, toodles.